Good afternoon, my dear audience, and warmest welcome to the Impact webinar, Transforming the Energy Transition, Practical Pathway with Low Carbon Fuels and Carbon Capture in APAC. My name is Honam Shah. I'm a senior content analyst from Leader Associates. It's my great honor and privilege to be your host for today's webinar. This webinar is also a virtual session of APAC's leading event dedicated to advancing the region's low carbon fuel future, APAC Low Carbon Fuels and CCUS Summit, which will take place from November 4th to November 5th at Perth, Western Australia. In addition to your participation to this webinar, we also look forward to meeting you in person at this flagship event, which brings the highest level decision makers across the entire CCUS and clean fuels value chain, including Woodside Energy, Beach Energy, Chevron, Government of Western Australia, JERA, Airbus, Boeing, Qantas, and much more to discuss the latest innovations and fill your business by meaningful connections. The Asia-Pacific region generates over half of the global CO2 emission, but attracts only a third of the low-carbon investment, highlighting the urgent need for scalable, commercial viable solutions. To balance its industrial competitiveness with climate goals, the region must adopt a dual-track approach, deploying CCUS to decarbonize the hard-to-abate sectors and legacy assets, while accelerating the scale of low-carbon fuels, such as SAF, e-fuels, and advanced biofuels to drive the future growth. In this high-level webinar, senior executives from the region's leading CCUS and low-carbon fuels developers will provide us with an insider's view of the flagship projects and strategic frameworks. Discussion will highlight commercial models that enable bankable projects, the latest advances in capture technology and fuel production, and the engineering and infrastructure requirement to scale solutions across a diverse market. To make this webinar a more interactive event, we generally encourage all of our audience to raise questions in the Q&A box, as we really have an amazing lineup of speakers for you today. CCUS isn't just a technology. It's one of the most promising solutions for advancing the deep emission cuts while keeping industry competitive and community scalable. To open up to this webinar, we are really thrilled to have Ms. Ursay Johnstone, the chair of CCUS Network Australia, who will walk us through how regional collaborations and real-world pathways are turning CCUS from concept to commercial reality. Ursay, it's such a pleasure to have you here with us today. The floor is yours.
Thank you, Holman.
Thank you.
Okay, so I was given quite a wide brief for the talk today. So I'm choosing to focus on the industry collaboration side of this, and specifically government and industry collaboration. So we're going to look at some different examples of how that might look and the way it plays into those practical pathways for emissions reduction in Asia-Pac, Australia, and a little bit globally. Next slide, please. So what are these available incentives and what are the compliance mechanisms? So otherwise known as what are the carrots and what are the sticks for this long-term decarbonisation at scale? I'm guessing I don't need to tell anyone on this call the way that we can tackle decarbonisation at scale with a CCS project. Next slide, please. Just a couple of Australian terms, because the first few slides are going to be looking at Australian projects. And so just so that we know ways in which the government has a role to play. There was a carbon tax in Australia, and when we had a change of government, that was replaced with a safeguard mechanism. We won't go into the ins and outs of what the safeguard mechanism is or the Clean Energy Regulator and why it came about, but suffice to say that this was reformed in 2023 under a change of government and effectively sets a cap to the emissions from these 215 facilities throughout Australia, and then that cap will fall year on year until we get to the year 2030 and likely beyond as well, and that there is also a limit to how many offsets can be used to achieve that fall in carbon, and those offsets can be no more than 30%. And they are in the form of what's known as an ACCU, which is an Australian carbon credit unit, which represents 1 tonne of CO2, either 1 tonne avoided by it not going in the atmosphere or 1 tonne that's drawn out of the atmosphere. So those two things we'll touch on in the ways that the government gets involved in projects in Australia. Next slide, please. So we're going to start off in Australia, and then we're going to spiral out into the region, and then we're finally going to touch on some of these other global examples of the ways that industry and government collaborate around the world. Next slide, please. So we're going to start close to home. I'm speaking to you from Perth, and off the west coast of Australia is the Gorgon project, which operates onshore but on an island, so it sits in state territory. And there is the Gorgon processing facility there for LNG, and associated that is the largest operational CCS project in the world at the moment, which is the Gorgon CCS project. Next slide, please. So this is a project that's been very long in the making. So discussions around the Gorgon LNG plant started way back in the early 2000s, and under successive governments, state and federal, and both sort of Labor and Liberal National, this has been a long supported project. But the reason that it exists at all as a CCS project was because it wasn't a requirement. So for the joint venture for Gorgon to go ahead and put the LNG plant on Barrow Island, there was a requirement that they would have to set up a CCS project, which is targeting around about 80% of the reservoir CO2 from those associated fields that feed back into the facility. And since the 2023 safeguard mechanism reforms, that is now a safeguard mechanism facility, and it has to now start reducing its emissions year on year. But of course, this had a very early start, and so therefore is in a place now to be up and running, albeit with some operational issues, but still, broadly speaking, successfully sequestering CO2. So the ways that the government's been involved in this one is basically by actually making the project go ahead. There was a little bit of seed funding early in the day, $60 million, albeit out of a much larger budget, and it's now a designated safeguard facility. So we can see, if we encapsulate why Gorgon as a CCS project exists, it's because it was the price of doing business. Next slide, please. So we'll now go to the next operational project in Australia, which is much more recent. This is the Moomba project in South Australia, albeit up near the border with Queensland. And this is an onshore project right sort of in the centre of Australia. And it is again associated with a gas processing facility, this time using a depleted gas reservoir that's being injected into along a 50-kilometre pipeline. Next slide. So this one is up and running already at the injection rate that it was hoping for, again targeting just that reservoir CO2, not any of the flue gas that was associated. I know there's a talk coming up straight after this from Beach around this project in particular, so I won't go into too many of the details. So let's look at the government role then. So the South Australian government has long had state greenhouse gas legislation in place, and interestingly, there is a royalty in the form of a rent payable for injected CO2. So there is a little bit of a revenue associated with the storage of CO2 in South Australia. And another way that the government was involved in this project is that the project only took the final investment decision once CCS became an eligible way to generate those carbon credit units. So this was a project that really needed that boost from the government to say, yes, you can claim a carbon credit unit for using a CCS fund. There was a little bit of direct funding here in 2021, albeit the cost of this project is much smaller, and it is a smaller project overall. But again, it's a safeguard mechanism facility, which would have had to look at ways of abatement anyway. And with this project already being very advanced and indeed operational now, this is also a project whereby reaching that safeguard mechanism facility cap is going to be a lot easier for this project. Next slide. So if we go up now to the Northern Territory, what's known as the Northern Territory Low Emissions Hub, which is located or will be located in Darwin's Middle Arm Peninsula. So this is a project that's still in the planning phases, but the idea is to co-locate gas processing facilities along with other carbon intensive industries, and to basically, in the way of any low carbon hub, to bring together a lot of different emitters, infrastructure, import export facilities. And we can see there that there are two possible locations for the storage of CO2 offshore from Darwin. So one is the Bayu Undan field, the depleted field, which is now ready as a CCS depleted field storage opportunity, and the other one is the aquifer associated with the Bonaparte CCS project. Next slide, please. So what's the role of the government in this one? So this is slightly different. Bayu-Undan is outside of jurisdiction of Australia. It is in the waters of Timor-Leste. And so we're going to need that transboundary bilateral agreements and considerations around the London Protocol. The Bonaparte CCS project, being more of a sort of a greenfield CCS project, has needed a lot more upfront data gathering, and that's come in the form of quite a few pre-competitive studies and a dedicated 2D seismic survey, all under sort of variations of the flagships funding and CCS R&D programs. In fact, that was my very first project that I worked on was in this area. We could argue that the government is involved in helping with the planning phases of the low emissions hub, which is CSIRO's involvement. And then there's another couple of ways that this project's a little bit different. So the operator of the Bonaparte CCS project is INPEX, which is partially a nationally operated oil company, as in 23% is owned by the Japanese government. And then similarly, this is the first CCS project in Australia that's been granted major project status. And along with that comes some sense of streamlined regulatory approvals and a bit of government facilitation there. So the emerging theme here is that all of these projects, to a greater or a lesser extent, have compliance issues, but also some help from government as well. Next slide. We're now going to leave Australia and we're going to start to circle out into the Asia-Pac region. And we'll first look at Malaysia. So here is probably the most known Malaysian CCS project, which is the Cassowary field, taking CO2 with a dedicated facility and a pipeline going out to the depleted field at M1. Next slide. So this is one of 5 to 7 CCS projects in Australia, and to a greater or lesser extent, they pretty much all involve Petronas, which is the national oil company or the nationally owned oil company, which has also been tasked with the development of CCS. And indeed, that CCS bill that came in just this year in 2025 has been written very much with Petronas in mind as well. So we can see here that if you have an NOC, you can quite quickly write the regulations, and then those two things can really accelerate the setup of CCS projects. And Malaysia is very much positioning itself to be that regional CCS hub. They're also going to need bilateral agreements if they're going to take imports from Japan, Korea, and Singapore, but we can see that's well in train. Next slide, please. And Indonesia also, as we can see from this map, has a lot of CCS projects that are at least in the assessment phase. So if we go on to the next slide. Again, we can see the role of the national oil company, in this case Pertamina, which is set up Pertamina Hulu Energy, to specifically look after CCUS projects. But interestingly here, this is now looking at a domestic allocation of pore space. So under the PR 14/2024, the permit holders are required to reserve 70% of the storage capacity for domestic sources. And then that further 30% does come with some conditions and strings attached. And we can also see that Pertamina has set up a shipping offshoot as well, PIS, looking into the liquefied CO2 transport. So this is a much more interventionist domestic allocation pore mandate. So let's see where else in the world that this pore mandate idea is also taken hold. So next slide. Let's go over to the EU. Now, all the various countries in the EU will have their own ways that they are going to have a CCS industry, but there is also a pore space mandate or a EU carbon storage obligation happening in the EU, and it's linked to the production historically of oil and gas. The reason they're doing this is they see it as a way to rapidly unlock that necessary storage by literally forcing those companies to find the pore space. Next slide. The USA, slightly different. This is coming much more under the obligation of a performance-based credit, much less around direct intervention in America, or at least in North America, in the US. And we can see that even now under the Trump administration, this has largely remained in place, albeit some things now are favouring parity for CO2 used for enhanced oil recovery, but still that emphasis on geological storage underground, albeit with some now restrictions on foreign entities of concern. So this is again favouring that sort of America first view of the world. Next slide. The UK has taken a little bit of a different approach. So this is partially direct funding and partially financing here. So they're looking at a CCUS cluster sequencing process. So track 1, those 2 projects shown here, HyNet and the East Coast Cluster, which are bringing together those aggregated industrial emitters. And then track 2, not shown here, will be hopefully underway by 2030. If we look at the next slide. You can go to the next slide, Holnham. Yeah, so it's quite a hefty amount of public funding here, £21 billion over 25 years. But the idea here is that it's not just direct grants, but also using contracts for difference. And I guess we see that now. It's a role that the Norwegian government played in the Northern Lights project, which is a way to de-risk the projects by guaranteeing long-term revenue. So it's taking away some of that risk associated with purely commercial CCS projects, of which there really are very few in the world. There has to be government involvement in some way or another as some sort of incentive or compliance measure. Next slide. And the final contracts for difference, and this is very hot off the press, it's really literally in the last couple of weeks, is that Germany now has gone on quite the journey, which is a major policy turn, by really embracing CCS in their decarbonization of heavy industry, and again through this carbon contracts for difference, which is a way that they are reimbursing firms and allowing them to reduce their exposure to the volatile energy prices and carbon markets. And my final slide is all about collaboration. Sorry, that's fine. My final slide is all about the collaboration. So I'm chair of the CCUS network. Our tagline is we want to foster collaboration and innovation all across the CCUS value chain. And we're actually holding a 2-day workshop on West Australian CCUS hubs. So if you're interested in becoming a member of the association or becoming a sponsor of that event, my email address is on the screen there now. And I'm very happy to take a couple of questions.
All right, thank you, Steve, for the really powerful and insightful start. I think your remarks truly highlight how collaboration and innovations are truly turning CCUS into a long-term decarbonization driver for Australia and beyond. So now, of course, let's dive into some of the questions from our audience. We had quite a few come in. So first of all, one audience asked why there are actually so few CCUS projects in Australia at the current stage. Could you please help us explain this?
Well, I'd say actually we have 2 operational projects, which is more than a lot of countries do in the region. And we have quite a few more in the pipeline as well. But I think it's clear to say that these are long-term, large-scale infrastructure projects, which are a number of years in the making, and it just has to have the right political climate for these to come to fruition. So we need that backing of stable government support. We do need the policies to not be flip-flopping around with a change of government. So both, I'd say the Gorgon project is a way of seeing that it survived all of those changes of government, whereas some other projects happened to come to fruition at a time when governments were really wanting to do policy reversals around things like carbon taxes and using other mechanisms to address or not address climate change. So it needs a stable investment market and a full reason to be. So there's loads of opportunities in Australia. It's just a case of everybody waiting to see what the policy support's going to be.
Yes. And the second question for you is more from a general perspective. Why do CCUS projects continue to lack the significant capacity required by model the climate scenarios?
Yes, so I'd say the word capacity when it comes to CCS is literally around how much do you think in a verified way that you can store underground. Again, I don't think we have any problem with finding places to put the CO2. It becomes much more at the other end of the value chain. So it's around what's compelling the emitters, what are the costs associated, can we bring those costs down? So there's a definite need for us to accelerate the rollout of CCS projects in the places where it makes sense to do so. But the actual capacity as in the geological storage capacity, isn't actually the limiting factor. I'd say it's much more around the things that we've looked at in this presentation, which is to do with policy support, incentives, and compliance measures.
Yes. I would say thank you so much for all of your inspiring answers, and I think that's a great way to set the tone for the rest of today's program. Thanks again for all your insights.
Thank you, Harlan.
Thank you. From one of Australia's most significant carbon capture sites to its broader decarbonization strategy, Beach Energy is actually taking bold steps to redefine what responsible energy production looks like in the 21st century. To share more about the journey from Moomba to net zero, please join me in welcoming Mr. Glenn Watts, the Chief Operating Officer at Beach Energy. Glenn, we are very delighted to have you here. The stage is yours right now. Please turn on your camera and your audio devices.
Thank you, Holman. I'm very appreciative of the opportunity to come and present today. I think just this presentation really, it goes so well with what Rosie was just talking about, and I think ultimately it's exciting to have a chance to share a little bit more about the Moomba CCS project, as well as Beach Energy and what we've been doing in terms of our decarbonization journey. So really, I think, again, Rosie did a fantastic job in setting the stage for carbon capture storage, carbon capture utilization storage. And Moomba CCS is really one of those projects that spanned different elements, which can include government support, sustainability commitments, what are the triggers for different companies at different times. With Moomba, it was really focused around the Cooper Basin production platform, which largely has to do with almost 60 years of production history, with a component of the gas stream being carbon dioxide. And so ultimately, Beach and the operator of the project, Santos, who are one of our close joint venture partners, worked closely together to identify opportunities to match what was our commitment, joint commitment to work towards a net zero outcome, as well as making sure that we could be compliant and aligned with what were emerging regulations in terms of safeguard mechanisms and how to best work within ACU frameworks and other types of state and federal perspectives. And I think that's an important balance, which I think Rosie touched on in a really good way in her presentation. As a brief introduction, I joined Beach Energy about a year ago. I have about 30 years of oil and gas experience, and that included about 13 years working with Santos, including in Moomba and associated with the Moomba CCS project. If we can go to the next slide, please. Now, really, this is a very, again, it aligns very much with what Rosie had said. Thankfully, the schematics are fairly similar. There was always an element of CO2 that was associated with the reservoir gas in the Cooper Basin. And so for many decades, as the gas was treated at Moomba and then sent for sales to different parts of the country, that CO2 would be vented. And so as part of the commitment towards working towards a net zero outcome and continuing to try and meet our own emissions reductions targets, that Moomba CCS project was born in conjunction with the work with the operator, Santos. This simple schematic shows really capturing that CO2 from the reservoir gas, doing some basic compression, dehydration, transporting it in a standard pipeline, and using depleted reservoirs. The real advantage that we have is, of course, 60 years of knowledge on the subsurface in this area, which provides a tremendous amount of information around the reservoir itself, the trapping mechanism, the sealing mechanism, how we would go about being able to monitor the reservoir conditions, the ability to have infrastructure in and around the area to provide superior monitoring from what a lot of other reservoirs and subsurface conditions would have, as well as that developed network, which made it simple to plan and install additional pipelines and wells. And then, of course, that depleted hydrocarbon reservoir that becomes our source of where we're going to put the CO2, it stored gas for millions of years, and it definitely is set up to handle the carbon dioxide. If we go to the next slide. And sorry, there's 3 here. Yeah, perfect. Now, really, I think this first tile, and these are a sampling of different quotes and statements. And I think really when you look at this first one, increasing capacity from 45 million to 6 billion tons of CO2 storage per year really speaks to the level of projects that Rosie had just talked to, and the importance of continuing to focus on getting as many of these projects into the pipeline, so to speak, as quickly as we can. Each one of these projects takes years in terms of working through the approvals and the actual execution pathway, as well as navigating the engagement with different levels of government. And so, of course, here in Australia, working with the state governments as well as the federal governments on what that CCS framework looks like. I think ultimately it is very clear that CCS is part of the solution, and it's an important part when you say, how do you manage aging infrastructure, different types of combustion engines that are used around the world, as well as different sources of CO2 that are either from oil and gas production or through manufacturing. There's going to be an ongoing need for safe, affordable, and reliable energy. And I think ultimately CCS, in conjunction with electrification and looking at using natural gas for manufacturing and peaking for electricity, it forms a very, very important relationship. If we go to the next slide, please. This is just a helpful tagline. And to me, I think when we look at it, Moomba CCS with a capacity of about 1.7 million tons per year of CO2 storage on the phase 1 that was executed and in place. You use something like this type of a number, Moomba CCS avoiding more emissions in 4 days than 10,000 electric cars avoid in 1 year. Now, I think it's important to acknowledge that both of these types of solutions are important. Electrification of combustion engines, as well as using CCS to offset different emission profiles. It's not one or the other. This is all, how do we continue to do more from an industry and really nationally and internationally to work towards our decarbonization goals. Capturing emitted CO2 ultimately could be a challenge. There are plenty of depleted reservoirs around the world. It is, how do you find suitable ways to capture that CO2 and be able to transport it? And that, again, one of the advantages of Moomba CCS is the pipeline infrastructure that can allow access to that facility from different areas, as well as potentially using technology like direct air capture and other technologies in the future to be able to capture CO2 and offset other industries that are either nationally or internationally. If we go to the next slide, please. Now, I think Moomba CCS, I often look at this as an example of what is a scalable and repeatable project. It is taking an existing facility, doing an add-on of additional either stripping, gathering, compression, and transportation infrastructure, which could be done as a bolt-on. And this is an example of something that could be done all around the world. And in fact, CCS is done in many other places globally. It was an important project, and we talked about Gorgon on the previous presentation, but ultimately this one was taking an aging existing facility, relifing, repurposing part of it, and then setting it up for a future, really the future utilization that was aligned with a decarbonization and net zero profile. So I think when I look at the APAC region and ultimately all the projects that are available through the region, it shows there is equipment that is essentially available off the shelf, and it's just a matter of working within the frameworks and finding the right reservoir and gathering system to be able to duplicate it. Our regional emission target cannot be reached without continuing to expand on our CCS opportunities. Ultimately, Beach is continuing to work at either reducing our emissions profile of existing equipment by finding opportunities to replace old equipment with newer equipment that is more efficient, and continuing to try and find a way to reduce the amount of combustion generation and emissions generators that we have across our field. That includes doing a series of ongoing emission studies, continuing to look at ongoing smaller projects, as well as these larger ones, which are like the Moomba CCS project. I think it fits as a great example of what we can do in Australia, and which can also support APAC at a larger level. Holnam, I'm happy to pause there and take any questions that people may have about that content.
Thank you, Glenn, for your really fascinating deep dive into beach energy transformation journey. I think it's really inspiring to see how the legacy assets can evolve into the anchor for the low carbon future. And of course, we have some interesting questions from our audience now, and I see a few exciting ones coming in. But first of all, could you please help explain what are the biggest challenges in planning and developing the Moomba project up until the operation?
Yeah, I think that is one of the most interesting things about this project. So the Moomba CCS project was essentially had to be constructed in while the plant was still in operation, and so you've got essentially an important gas production facility, a major hazard facility in Australia, that is critical for providing domestic and international gas supplies, and then continuing to find a way to add on the CO2 handling and compression, as well as transportation equipment, without interrupting the supply of gas from the facility. And so I think that was one of the ones where Santos as operator and Beach worked closely together on the construction and commissioning of an integrated brownfield execution project. And I think one of the key factors of this was the fact that the project, when it came online, was able to exceed the ramp rate and get up to nameplate and beyond nameplate in the first couple of months. And so I think the performance and reliability of the equipment has been above expectations when we look at where we're at in the first year. I think the other key challenge that we had to navigate was just that regulatory piece, working with the state and federal governments. How do we try and incorporate a decarbonization framework, which includes things like the ACCUs and decarbonization incentives, but also how do you do that while you've got an existing facility and a production profile? The subsurface assurance, I think, was, again, a big part of this was if you've got a field and a facility that is in many ways 60 plus years old, how do you make sure that you put in place the right monitoring to ensure that when you put that CO2 into the reservoir, that you've got the right assurances that it's going to stay there. And so that was a big part of it in terms of abandoning some of the older wells, drilling some new wells with the required CO2 capability for the pipelines and the wells, and then putting in place a series of monitoring systems and making sure that we had a robust assurance process for the wells, whether it was during the injection or the surrounding surveillance.
Thanks again, Glenn, for all this thoughtful answers and for sharing us the industry leadership in decarbonization is not just possible, but already happening. Thanks again for all of your insights today.
No, you're very welcome.
As the world explores ways to connect emitter with storage sets, CO2 shipping is becoming one of the most exciting frontiers in the CCUS value chain. Japan's NYK line is leading this charge, building the infrastructure and innovation needed to make it a reality across the APAC region. To tell us more about their groundbreaking work in CO2 transport, please welcome Mr. Masaki Ono, the General Manager of the Offshore Business Group at NYK Line. Masaki-san, the floor is yours. Welcome on stage.
Thank you, Holnam. Hello, everyone. My name is Masaki Ono from Offshore Business Group NYK Line. Thank you for having me today. This is a great opportunity for NYK for presenting our CCS strategy today. So let's start. Next slide, please. So this is just brief explanation about NYK itself. We are founded in 1885. This year is 140 years anniversary. and employees 35,000 employees overall, all over the world. And we are now operating 886 vessels, including car carriers, bulk carriers, tankers, LNG carriers, something like that. And next slide, please. So NYK CCS project initiatives. NYK, our offshore business group, is already operating geophysical vessels as well as sea drilling vessels. These could be utilized for development side and also monitoring side. And now we are developing LCO2 carriers through our joint venture KNCC. Next slide, please. So KNCC is our joint venture between NYK and the Norwegian Knutsen Group. This is the company established in 2022 and providing 3 CO2 transportation modes, which is low pressure, medium pressure, and elevated pressures. So you can see in the bottom, KNCC has already AIP for all 3 types of vessels from classification society. So LP, EP can be more bigger, up to 80,000 cubic meters, and MP is up to 20,000 cubic meters at this moment. And you may know about LP and MP more. So EP is technology of KNCC. So I would like to explain about the EP CO2 shipping in detail today. So next slide, please. This is a brief design of EP vessel using the CTC means cargo tank cylinder. So CTC is made by usual normal steel, and one CTC has 37 cubic meters, and gathering these tanks into the vessel. Considering other type of tanks like type C tanks, this CTC can be produced more quickly as the normal steel maker, a pipeline maker can build this CTC. So next slide, please. And this slide shows lower OPEX throughout the CCS value chain. So as you can see, from gas at the emission side and injection side. So for LP mode, CO2 gas have to be cooling to up to minus 50 degrees and also 6 to 10 bar. And medium pressure mode have to be down to minus 30 degrees. But EP mode, it's gonna be 0 to 10 degrees and 34 to 45 bar, which reduce the energy usage comparing to MP mode, LP mode. And also consumption of electricity is also less, and energy is also less. So which means that LP mode could be reduced the OPEX for the value chain, total value chain. Next slide, please. This slide shows we had, together with the Chiyoda Corporation and NYK and KNCC, we had a joint study to evaluate 3 modes in last year. So you can see that transportation pink color itself is not so different between MPLP and EP. But in total, considering the value chain, liquefaction, storage, loading, and unloading side, so the total cost can be reduced by EP mode rather than MP or LP. And next slide, please. So now NYK's activity is looking for total value chain solution rather than only marine transportation. So optimization of capturing side and liquefaction side, and also injection side, developing DIO. And our purpose is to lower the cost throughout the CCS value chain. Next slide, please. DIO vessel for CCS has not been developed yet, but together with the Knudsen, we have another joint venture company operating shuttle tanker, crude oil shuttle tankers named KNOT. These shuttle tankers, some of such shuttle tankers have injection, chemical injection experience for EOR. So those shuttle tankers have direct positioning DP. So using this KNOT's experience for direct injection, KNCC will develop such a DIO for CO2. Next slide, please. And also liquefaction side, for emitter side, we are now collaborating with NLC Explorer and also Class NK to develop floating liquefied storage unit, FLSU. So using EP technologies and liquefaction plant to be installed on offshore. So you can see in the map, current typical project is now considering each emitter has each liquefaction plant. But offshore solution, they don't need a liquefaction plant onshore. And using the pipeline transfer the gas to this FLSU, and then liquefied CO2 to be offloaded into a CO2 vessel in order to transport to other countries. Next slide, please. This slide shows the impurity tolerance and capture cost under EP condition. MPLP systems require high purity CO2, like 99% or something, and have a narrow tolerance for impurities, leading to higher capture cost. You can see left-hand side, which is the study by PACE CCS. So EP mode offer greater flexibility, tolerating certain impurities. Which leading the lower CO2 capturing cost. So right-hand side, sorry in Japanese, but if EP mode can accept lower impurity rather than current amine operation, so we can consider other more economical type of absorption, like a membrane or like a other chemical. So I think the EP can be reduced, such capturing side as well. Next slide. This is the final one. Yes. This is my presentation about NYK CCS strategy. So happy to take questions.
For sharing the NYK Line's incredible efforts in building a carbon neutral maritime future. And it's really inspiring to see how Japan is spearheading such a crucial part of the CCS ecosystem. And now let's move to our Q&A segment. So first of all, what regulatory or legal challenges currently hinder the cross-border transport or storage of the captured CO2 in the APAC region?
Especially in APEC region in Asia, the regulation hurdle is first one is G2G discussion to establish the bilateral agreements to transport CO2 from, for example, Japan to Australia, Indonesia, Malaysia, something like that. So once these regulation is materialized, so we can discuss with government or other private companies to develop such a CO2 project. So I hope that such a G2G discussion will be completing soon.
And yeah, and thanks once again for your time and painting such a clear picture of the road ahead for the CO2 shipping in APAC.
Thank you very much.
Thank you. From pioneering global CCUS hubs to deploying the cutting-edge subsurface technologies, SLB New Energy has been at the forefront of the scaling carbon capture project worldwide. We're here to share what it really takes to bring CCUS from pilot to commercial scales, the challenges, license, and technology breakthroughs. Please welcome Mr. Musa Namavar, Director of Carbon Solution Asia Pacific at SLB New Energy. Musa, the floor is yours. Welcome to your session.
Hi, Holnam, and good afternoon, good morning, and good time to everybody. It's a pleasure to be here. Holnam, should I cast my slides, or you have it there that you'll bring it up? Okay.
You can share your screen right now.
Okay, I can just go ahead. Okay, so I have the screen as you're showing, and that's good enough. I can continue on your screen, yeah?
Yes, please go ahead.
Okay, so yeah, thanks for the opportunity. My name is Musa. I look after the CCS business of SLB in Asia Pacific. What I'm going to talk about here in this interesting event, very interesting event, is I wanted to touch a little bit about specifics, start with specifics of CCS in Asia, what areas of focus as an industry we need to have, and then moving to technologies that we as SLB, as a technology provider, as one of the technology providers, and industry generally, it's moving towards when it comes to carbon storage and carbon capture. So I will touch those two topics quickly as we move forward. Now, on the next slide, when we look at the ways that we are going to decarbonize the whole world that we have to achieve, there are multiple pathways and scenarios that we need to get to net zero. In all of these scenarios, of course, first of all, they recognize CCS is needed and it's impossible to achieve net zero without it. And the second thing is that the gap is significant. We are currently 40-50 million tons. We need to achieve 6 gigatons. So this is a significant target that we have to achieve. And then to achieve that, we need to lower the costs and lower the risks. On the next slide, when we talk about overall CCS, this is a very complex, quite complex ecosystem. And there are many interdependencies, in which, if one is not there, either the project doesn't happen or project gets delayed or gets cancelled. On one hand, we have, of course, the policies, regulations that needs to be in place. And that I'm sure that there is enough talks about it in the industry to achieve that. On the other hand, we need suitable storage sites, the right amount of storage volume, right injectivity, to have confidence about containment of CO2 in the subsurface. On the other hand, we have emitters. They need to have right technologies when it comes to carbon capture, cost-effective technologies. We need to have right structure and partnerships around to make these projects happen. And finally, as Masaki-san very well presented, we need the right transportation solutions as well. If we are very lucky and our source is close to sink, then pipelines, maybe the answer is much easier. But shipping is going to play a key role in our region. And that's what takes me to the next slide. In next slides, I want to touch a little bit about Asia context. In Asia, we hold more than 50% of the global emissions. Here we are, some of the specific topics and areas that I want to talk, elaborate a little bit more about. We say regulations policies are very critical. In Asia, it's not mature yet. We've got places like Australia with more advanced regulations in places. Regulation-wise, the rest of the region is catching up. It's coming up. Policies is what we are actually missing quite a bit. And that one, it's moving forward. The good news is that it's moving forward, but that definitely needs to be in place for projects to happen. On the second line, when we look at distribution of major emission sources and suitable storage sites, this is a bit more unique in Asia as well. Countries we have with a lot of emissions and lack of storage sites in Northeast Asia, Japan, Korea. And then you've got countries with abandoned storage sites, Australia, Malaysia, Indonesia, for example. So that implies a complex ecosystem that we have to put in place. Cross-border CO2 movement, shipping again becomes very critical. Projects are at very early stage. Most of the projects that we are looking at, the dots that you see on the maps are the major CCS hubs or projects that are defined in our region. Different sources indicate different numbers, 60 to 80 projects, between 70 to 100 million tons of MTPA defined. And majority of these projects are at early stages. So it's a must. We have an opportunity for sure, and it's a very critical requirement to de-risk these projects. When we say de-risk is how we are able to plan effectively upfront in all of these projects to proceed with a success, higher chance of success. Asia, it's world's industrial powerhouse. That means a lot of industries, especially in hard-to-abate, that needs decarbonization. So we also have high energy demand in our region, and that means CCS will need to play a key role here. Having a carbon capture solution that is able to address our hard-to-abate sector in Asia is very critical. And last point, but I think very important, is we need to share the lessons learned from the rest of the regions, bring it to Asia, and within our region also share know-how and best practices. So these are the few angles that I think is critical for Asia to consider when we are scaling it up. Now, next slide, I enough talked about the general context. Let me talk a little bit about technologies, right? So when we develop a storage sites, there are three key performance factors that we need to address. And these are about how much CO2 we can store, what injectivity rates we need, and will there not be any leakage? We have assurance about containment of CO2. So the role of us as technology company is to identify, measure, and characterize the reservoir storage capacities very well upfront. That is a lot of de-risking that happens early on. We need to optimize injection performance and long-term well injectivity, bring it up. That is again, as technology providers, we have a lot of means to do that. And then we have technologies and techniques to monitor the storage site containment, so what is very well known as MMV. Those are the areas and role of technology providers like us to ensure the storage sites are de-risked and are successful when it comes to their containment, injectivity and containment. Moreover, next slide, when we talk about areas of specifically where SLB is bringing a lot of ideas to the table is standardization, so we need to standardize workflows and methodologies in CCS in order to impact at a scale. Front-loading risk assessments, we said, is very critical. Having optimum design using modeling and simulations, risk assessment is critical, and that is the first two solutions on the left that you see there: site screening, ranking, site evaluation. These solutions are able to bring the risk of the projects down upfront, but very methodologically and very systematic in a systematic approach. We've been investing in technologies to enable these standardization and workflows to enable. And that is a critical role, an example of areas that I want to bring up that what we are doing. Specifically, talking about Asia, we've got a lot of depleted oil and gas fields. That means actually it's a good news, because it means that we have a lot of storage sites, but it comes with inherited risk of wells needs to be assessed for their integrity and then remedied if it's required. We announced earlier this year a solution called well integrity assessment. Again, having a standardized and systematic approach to address the well integrity issues in or challenges or assessments within a field in the context of CCS. So these are some examples that I wanted to share with you in the short time when it comes to a storage side. Moving on to the next slide. A bit about carbon capture as well, and I think this is a very hot topic, and I'm very excited to talk a little bit about it in our context of Asia, what we are doing. So first of all, this slide shows the portfolio of solutions that SLB Capturi, our post-combustion carbon capture company, has commercially in the market. What you see here, there are two flagship products, Just Catch and Big Catch. Just Catch is the second one that you see in the list. This is a modular technology that it's through the modularization, we've optimized the process. We brought a lot of cost efficiency to the table. The system that you see here has a capacity of either 100,000 tons or 400,000 tons, and you're able to stack them next to each other, increase the capacity. So through this modularization, we are able to get a lot of advantages that I'll show you on the next slide. On the other hand, I want you to look at the far right, Big Catch. Big Catch system on the previous slide. Sorry, hold on, I confused you. On the Big Catch system, it's a custom design solution. This custom design solution we are able to address megaton carbon capture designs. When we need the advanced heat integration or advanced installation, or maybe the surface area is very specific. That is where we go with custom design solutions around the plants. And also we have solutions about testing. Just Test is a mobile test unit, a very compact system that is able to do the entire carbon capture assessment in few containers and easily movable, and you're able to test new flue gases if needed to be done here. So this is a portfolio that we have. On the next slide, if I can quickly touch what we are doing in our modular technology. This modular technology, I mentioned that through modularity, we've achieved a lot of efficiencies and advantages. One of the key ones is actually the footprint. We were able to reduce the footprint significantly, and then at the same time, you are able to transport these units easier. They're prefabricated. You move it to the location. You install them, assemble them, and you're able to address a lot of challenges in Asia, for example, in the regions in Northeast Asia, in Japan, Korea, in Taiwan, and a lot of other regions that we have space scarcity. footprint becomes very critical, and this is how we are able to address it through this modular system. Beside a lot of other advantages that in a short time I'll not touch it. I'll show you two pictures, then I'll end my presentation. Next slide, a picture of a project that we're delivering with this system that you saw, Just Catch. This is a project that we delivered actually in Q1 this year. This is a waste-to-energy plant in Netherlands that we delivered. Is 100,000 tons. And the Just Catch system here actually is almost hidden. It's the light green structure that you see in the center. That is the Just Catch system, very small footprint, and it's operating in a CCU environment. This is a first-in-kind project that was delivered in Europe and is operating currently. On the next slide, another example that I wanted to show you, first ever cement, commercial scale cement facility was we are doing carbon capture in it. This is in Norway. We are capturing 400,000 tons, very complex project, but thanks to the good design that we have, we were able to accommodate just a big catch, 400,000 tons capacity. And the CO2 of this is already being shipped to the famous Northern Light project. With that, I enter my presentation. I wanted to thank you for your attention. I hope I added a little bit to your knowledge. Please reach out to me if you have any questions, any interest in these technologies. I'll be happy to take any further questions that may come up, Holnam. Yeah.
Thank you, Mr. for your insightful presentation and your perspective on scaling CCUS with data-driven innovation is actually a great reminder that the technology to decarbonize the heavy industry is already within the reach. And we'll now move into our Q&A portion. So first of all, what are the viable carbon solutions offered for the petrochemical sector in your mind?
No, it's a good question. It's I think it's a wide question. The way I would answer is that decarbonizing petrochemical, first of all, is tough because you've got many type of emissions. You've got emissions from the process chemistry, and also you've got some emissions from burning fuel. So yeah, there's not one single silver bullet, I would say. But what we need to have is a portfolio approach. First, of course, like any other industry, everybody goes towards squeezing out the energy efficiency, heat recovery, all of the better insulation or those type of solution is first. But CCS can play a key role here, in addressing emissions, mostly from the thermal units first, where significant combustion happens in crackers, for example, in furnace burners, in steam generation processes. For these, we are able to apply the existing carbon capture technologies. The SLB Capturi, for example, technology applies very well to this environment. And also then we've got certain processes that they have inherited CO2. CO2 is as a byproduct of the process, like reformers. And that, in there, then CO2 needs to be stored, and that's how we will achieve some form of decarbonization. Yeah. Of course, in a longer or in midterm run, there is a lot of ideas about shifting towards electrification or maybe using low carbon fuel like low carbon hydrogen. All of that is relevant, that it needs to be done. In summary, yeah, it's not a single solution. I think it's there needs to be a combination of solutions needs to come, and this will really depend on the geography, on availability of what feedstocks you have in that region. Is green energy available in that region or not? What regulation requirements are there? Based on all these, then the right strategy for decarbonizing petrochem will be used. Yeah.
Thank you again, Michelle, for sharing your expertise and for showing us how collaboration and advanced technology can accelerate the region's net zero journey. Sustainable aviation fuel is reshaping the way we think about flying, turning waste and receipt into the high-performance jet fuel and cutting life cycle emission by up to 80%. Here to share how Neste, the world's largest SAF producer, is scaling production and making SAF commercially available worldwide. Please welcome Mr. Samuel Chong, the Commercial Manager for Renewable Fuels at Neste. Samuel, we're excited to hear from you. The floor is yours right now.
Thank you, Honam, for inviting Neste to present at this session. Allow me to share my screen. Okay, after hearing from Onishi-san from the marine side of things in terms of marine fuels and ammonia being a solution, let us take to the skies. My name is Sam, last name Chong. I'm the commercial manager responsible for Neste Renewable Fuels in Asia Pacific. And today's presentation and discussion is really about some of the key considerations for producing innovative and commercially available SAF or sustainable aviation fuel for the aviation industry as we move forward to reducing emissions in that particular segment. So globally, for Neste, we create different renewable solutions and produce them, supply to various counterparties to help the world decarbonize. The topic for discussion today is pertaining to aviation, and with that is about SAF. So on a broader lens, aviation and marine in total accounts for about 4 to 6% of the global emissions, with aviation at about 2.5 to 3%. That is equivalent to about 800 million tons of CO2 emissions globally as of 2024. So in order for us to decarbonize aviation, SAF has been recognized by IATA as one of the key levers that can achieve this objective. So like I mentioned, SAF essentially helps to reduce emissions for aviation together with the rest of the solutions. For example, improving operational efficiencies, technologies that are available that can be implemented for airport operations. But the key lever to really reduce emissions is really from flying. And in terms of that, about up to 65 to 70% as estimated by various sources that that emission can be reduced by essentially replacing the current fossil jet A1 that is being used in aviation with SAF itself. The impact of Neste's SAF, for that matter, across the life cycle of the fuel in its neat form, you can reduce the emissions for aviation, particularly for the fuel itself, up to 80% versus conventional jet A1 itself. For our capabilities in Neste, that's what Honam has mentioned, we are still by far the largest SAF producer globally, and our capacities have been growing year on year. In 2025, this year, the total capacity globally for SAF in Neste stands at about 1.5 million tons, with expansions expected to be completed in Rotterdam by 2027. That will bring our total capacity to about 2.2 million tons per annum. I believe that the theme in the various discussions that we have been having today, be it for CCS or for marine itself, in order to really decarbonize or accelerate the adoption of various solutions, you really need an ecosystem with partners in the value chain to achieve that. And for that, we have partnered with major airlines in order to accelerate the adoption of SAF, as well as various fuel distributors such as Itochu that you see on the screen over here, in order to bring the fuel into various airports globally. So some of the commercially, I would say, approved technology pathways for SAF. On this page over here is a simplified one. There are a couple of examples. First one is biodiesel. As you hear about this particular solution in industry, biodiesel is actually methyl ester that is produced through the esterification process. So for that, it's not able to produce SAF, whereas for the second tab you are seeing over there for hydrotreating, it is actually one of the more mature technology pathways which Neste is also adopting to produce SAF itself. And it is a drop-in fuel that we produce in terms of the SAF that, when blended with fossil jet A1, is certified to ASTM D1655 standards, which is then approved for supply into various airports globally. Last but not least, for major refiners, oil producers per se, they have been embarking on the co-processing front in terms of producing SAF as well by retrofitting the current fossil oil refinery, and that can be available as well, but it is capped at about 5% of the content that can be dropped in or blended with conventional jet A1. So a bit on Neste of the process that we use. This is a highly simplified page that we put together. For Neste, we source for raw materials globally. Some of the classic examples, which we probably will hear from the industry, includes used cooking oil, animal waste fats, and we process the waste through various steps. The second, which is a pre-treatment step to get rid of most of the impurities, and then it goes through a patented technology known as Next BTL, which is really hydrotreating, that allows us to remove most of the oxygen molecules and form a straight chain paraffinic molecule itself. And that stream is further fractionated to produce renewable fuels, chiefly renewable diesel and SAF. And once the tanks are batched, that's when we are ready to supply the fuel to various locations. So we talk on SAF. One of the key questions that routinely pop up during discussions is about how much feedstock is available to enable the expansion of SAF capacities. On this page over here, it's a collaboration together with World Economic Forum in a paper known as Clean Skies for Tomorrow, where there's a forecast on the amount of waste and residues available, together with the rest of the available untapped potential feedstocks that could potentially be harvested in the years to come. Right now, if you look at this page, waste and residues constitutes the bulk of the feedstock per se, and the quantity is estimated to be, give or take, about 50 million tons by 2050. And as you go up the scale, there are other technologies of feedstocks available, such as noble vegetable oils, lignocellulosic, and last but not least, which is, I think, the one of the key enablers to really accelerate the growth of SAF is really through power to liquid. And that involves, of course, carbon capture. So for Neste, at this point of time, we are heavily invested in the HEFA technology, which is hydrotreating, hydroprocessed esters and fatty acids to produce a renewable fuel. And on the innovation front, we are also invested in further developing different feedstocks that could be used to produce renewable fuels. And they include novel vegetable oils, which are really feedstocks that is grown on degraded land, land that is no longer viable for food crop, and of course lignocellulosic, which is really biomass that we are looking to process and turn it into renewable fuel. From a supply and demand balance perspective, it is forecasted that by 2030, there'll be about 40 million tons per year of waste and residues available in various parts of the world that could be, in a way, collected, aggregated, or harvested, and turn that into a renewable fuel. But really, the question is what happens beyond 2030, 2040, and even 2050? And like I mentioned in the previous pitch, novel vegetable oils remains something that's like I just mentioned, novel vegetable oils remains one of the interesting potential, high potential feedstocks that we are really embarking on developing, and work is being done to further broaden our feedstock envelope to process some of these, followed by lignocellulosic, and last but not least is really power to liquid, whereby Neste is embarking on various trials, not at a commercial scale yet, in order to process that and turn that into renewable fuel. So, last but not least, really to grow the market for SAF, we talk about the production pathways briefly. We talk about feedstock availability, but really on the demand side, to really enable the investments in SAF and to accelerate the adoption of SAF, you will need, I would say, three key buckets that we put on this page over here. The first one is really policy support in terms of mandates that are available that stipulates the use of SAF as recognized by Refuel EU, which has kicked in this year in Europe itself, for essentially a certain percentage of SAF that must be used for all departing flights from Europe itself. The second portion is really in the voluntary market, where airlines under ICAO will look to decarbonize, and SAF remains a key lever, particularly when you look at Corsair, which will kick in 2027. So that will form the second pillar in terms of growing the demand. And last but not least, is really about innovation, whereby companies continue to focus on developing broader pathways and different feedstocks at a more competitive cost to expand the expansion of production of SAF that will help to hopefully bring down the cost of SAF and accelerate the adoption across the aviation sector. And that's very quickly what I had. Thank you.
Thank you so much, Samuel, for the brilliant presentation. And Nestle's innovation story is truly one of the most inspiring examples of how sustainability and profitability can go hand in hand. Aircraft manufacturers are redefining the aviation sustainability story from integrating SAF and hybrid electric propulsion to exploring hydrogen-powered flight. To offer an OEM perspective on how technology and design innovations are driving this transformation, please welcome Ms. Malika Ramakrishna, Director of Promotion Strategy Commercial Aviation at Embraer Asia Pacific. So Malika, thank you so much for joining us. The floor is yours right now.
Thank you for the invite, Holnam. I hope I'm audible.
Yes, I can hear you good.
I'm just going to share my presentation first. Will you be sharing on your side? Okay. All right, it's good afternoon, everyone, and it's a pleasure to join you all today, although it's in a virtual mode. And I'm happy to share Embraer's sustainability journey and how an OEM supports the decarbonization of the aviation industry. If you can move to the next slide, please. So a quick introduction about Embraer before we start with sharing our sustainability goals and actions. So Embraer is, we operate across 4 different business units: commercial aviation, we have executive jets, defense and security, and services and support. We are headquartered in Brazil and have 20,000 employees all around the world. And we turned 56 years as of 2025. Next slide, please. So we have currently delivered over 9,000 aircraft in more than 100 countries. Next slide, please. And we'll now talk about how Embraer as a company is deeply embedded in sustainability. Next slide, please. So here are, as you're very familiar with, our Scope 1, Scope 2, and Scope 3 commitments as a OEM. So under Scope 1 and Scope 2, we are committed to carbon neutral growth since 2022, and we are targeting carbon neutrality from 2040. And how do we plan to achieve this? So we are regularly using SAF in our operations since 2021 in production flights and ferry flights, test flights, and also at our executive jets facility in Melbourne in the USA. And we're targeting reaching 25% SAF in our operations by 2040. And coming to Scope 2, which is associated with any electricity that's consumed in our operations, we are targeting 100% energy from renewable sources by 2030. And I'm really proud to share that as of 2024, all the energy that's consumed in our facilities in Brazil, 100% of the energy comes from renewable sources. Now, moving on to Scope 3, we are committed to achieving net zero emissions as per the industry target by 2050. And Scope 3, as you all know, is a bit tricky because most of these emissions come from the operators who use our aircraft, which are mostly airlines, right? So as an OEM, our primary responsibility is to make sure that we can produce or manufacture aircraft that are fuel efficient and clean. And in that regard, the E-Jets E2 is one of the world's most sustainable narrow-body aircraft in the market today, and it offers a 29% reduction in fuel burn compared to the previous models. And the second thing as a OEM is also in reducing the Scope 3 emissions is making sure our aircraft is SAF compatible. So today the E-Jets family is already certified to fly with 50% SAF, and we're targeting 100% SAF compatibility by 2030. And we're also continuously improving and making sure our current aircraft family are more fuel efficient and help reduce emissions further. And we're also exploring new technologies, clean technologies related to electric and hydrogen, which I'll talk about a little later in my presentation. Next slide, please. So although sustainability has become a buzzword in recent years, if you can look at this milestone here, Embraer has been working with biofuels for over 2 decades now. In fact, in 2004 was when we launched Ipanema, which is the world's first and even today the only aircraft certified to operate with 100% ethanol. And since 2011 to 2016, we have been testing various SAF blends, and we've also partnered with Azul, GE, and KLM in pioneering flights using SAF blends. In 2022, we had a very special milestone where we successfully completed flight tests on the E195 E2 with 100% SAF. Next slide, please. Right here, and you can see Embraer is also partnering with United Airline Ventures Sustainable Flight Fund. This is an industry investment vehicle that is focused on scaling SAF startups and technology. So this is where we major aviation stakeholders pool capital and target the whole value chain, starting from feedstock development all the way until refining capacity. Next slide, please. One more slide. And coming back to our product, it's important to emphasize that although we are exploring alternate propulsion technologies, the role that currently available products play in reducing emissions cannot be emphasized enough. If you can move to the next slide, please. So if you look at the combined outlook by ICAO and the ATAG and IATA, fleet renewal can actually reduce emissions by up to 20% in the short time frame, which means renewing your older generation aircraft to more newer generation fuel efficient aircraft. And the E2 today is one of the most fuel efficient aircraft out there, which reduces your fuel burn and ensures that we have less emissions with each flight. Next slide, please. And when we were designing the E2, we made sure that the sustainability was not reflected just in the performance alone, but also on the interior. So it's sustainable inside out. Next slide, please. So within the E2 cabin, we have integrated sustainable materials and circular economy principles. For example, the carpets in the E2 are made from a material called EcoNil, which is prepared from recycled ocean waste. And we've also switched to more energy efficient LED lighting inside the cabin. The toilets on the E2s use half the flush water volume as it's compared to its predecessors. So it not only saves water, but it also reduces the weight and in turn, results in lower fuel burn. We've also expanded the 3D printing process to more parts in the cabin. So 3D printing not only helps reduce aircraft weight, but it also lessens the material waste that is produced. So we are working very hard on making sure that the cabin is as sustainable as it could be, and not just from a point of view of current point of view, but also in terms of easier disassembly and also recyclable parts once it reaches end of life. Next slide, please. We'll take a quick look at what we are planning ahead to ensure that the future is sustainable. Next slide, please. So these are some of the partnerships that we have ongoing with companies around the world on different fronts. So you can see here that, for example, we have a joint venture with Japan's NIDA Corporation to advance the development of electric propulsion systems. We're also working with CPQD on the development of high voltage batteries for our next generation aircraft, and not just development of batteries, but also thinking thinking about, how these high voltage batteries are going to be recycled and disposed. We're also working with climate tech startups like Greentown Labs and Sustainable Aero Labs to accelerate innovation on the sustainable aviation. So these are some of the partnerships that we are currently working on to make sure that we collaborate together as an industry to reach our goal of net zero emissions. Next slide, please. This is a quick look of Energia family. So this was launched, these concepts were launched in 2021, and the objective was to offer a range of platforms for different suppliers and to integrate their technologies onto. Right? And since 2021, over the years, it has evolved quite a lot based on inputs from our Energia advisory group that consists of major stakeholders from the industry. So today we have 3 concepts that we are working on with different suppliers. One is the hybrid electric version, which can use either Jet A or SAF, and where we are looking at technology readiness by early 2030s. We also have the Energia fuel cell, which has the potential to be the first clean hydrogen aircraft, and technology readiness could be somewhere in the late 2030s, depending on how mature the infrastructure and the ecosystem will be. And the third is the dual fuel concept, wherein you could power the gas turbine using either SAF or hydrogen. Next slide, please. This is a quick snapshot of our sustainability roadmap to conclude how an OEM works together with different across the supply chain to make sure that we have the most efficient aircraft today to ensure that airlines can reduce their emissions and further improve their operations. And along the way, we are making sure that our aircraft will be ready with 100% SAF compatibility. And we're also exploring alternate propulsion technologies to meet the future needs of the industry. Thank you very much for your time today.
Thank you, Malika, for your forward-thinking presentation and for sharing how Embraer is reimagining the skies of tomorrow. And we will now take a question to wrap up this fascinating session. How can OEM take significant differences, and are most of their emissions within the scope 3?
Yeah, that's a great question. It is true that most of our emissions come under scope 3 because it depends on the operators of our aircraft, who are mostly airlines. But I do believe OEMs have a very big role to play and can make a big impact. One, by designing the most efficient aircraft so that airlines can use the aircraft and reduce their emissions. I think this is critical because airlines are working very hard to meet their decarbonization targets, and we do have very stringent regulations today, and also CORSIA obligations which will kick in, mandatory CORSIA obligations which will kick in very soon. So having the most efficient aircraft available is one of the primary responsibility of an OEM, and we can make a big impact there. The second one would be to make sure your aircraft is SAF ready, because although right now we are struggling with SAF supply, but once there is enough supply in the market and then the mandates kick in, the aircraft need to be ready by then to be compatible with, even if it is up to 100% SAF, and that's what we as an OEM are doing today. And the third is to make sure that we are exploring alternate technologies to make sure that of course SAF is going to be a cornerstone for near term reducing efficiencies in the near term, but we also need to look beyond into the future to make sure that we are looking at alternate technologies. So I think these are the 3 areas where OEMs can make a significant impact in decarbonizing the industry.
Yeah. Thank you once again, Malika, for those inspiring insights, and I think that's a great way to conclude our program today. Thank you.
Thank you very much for the invitation.
Ladies and gentlemen, that brings us to the close of today's webinar, Transforming the Energy Transition Practical Pathway with Low Carbon Fuels and Carbon Capture in APAC. Over the past 90 minutes, we explore how Asia Pacific can turn ambition into action. On behalf of the organizing committee, I'd like to extend our sincere thanks to all of our distinguished speakers for sharing their expertise and visions. And thank you to all of our audience for your engagement and for raising the questions. Last but not the least, please kindly be reminded that this webinar is also a virtual session of APAC's leading event dedicated to advancing the region's low-carbon fuels future, APAC Low Carbon Fuels and CCUS Summit, which will take place from November 4th to November 5th in Perth, Western Australia. In addition to your participation today, we also look forward to meeting you in person at our flagship event, which will bring together the highest level decision makers across the entire CCUS and clean fuels value chain. We hope today's webinar leaves you inspired with actionable insights to advance CCUS and low carbon fuels initiatives in your own projects and regions. We look forward to continuing this conversation at our APAC Low Carbon Fuels and CCUS Summit next month with all of you. And thank you, and see you next time.
Thank you.